come and study with Tanzania Institute of Education.
Hello, Form 4 students. Welcome to our lovely lesson of mathematics. In our today's session, we shall have a look on the fourth topic of Form 4, and that is probability. Before we proceed, as it is our culture, you have to sit properly with all the working accessory with you. In addition, in our learning tools, today we can have, if you have a coin, that is one of the learning accessory, and there is another thing here, you can see it. It has got 6 sides. We call it a die. A die is numbered. It's numbered 1. It has got 2. It has got 3. It has got 4. It has got 5 dots, as you can see them. And the last part, it has got 6. This we call it a die. There are other things which we use them when we are learning probability. We will introduce them as we proceed. To be together, I'm your teacher, Pascal Titus Majebele. Welcome. Let us start with the concept. Actually, everything you start with the concept, idea, the definition. What is the probability? It is the subject which touches a lot of things in our daily life. Normally, in our everyday life, we have the situation where we face uncertainty situations. When I say uncertainty situation, hope you understand them. A situation where it is difficult to make a decision. To be together, consider, for example, here, when an equally strong team, for example, meet, it is very difficult to predict which of the two teams will emerge the winner, or what will be the outcome, what will be the results of the game. Not only that, but if I take my coin here and I toss it, can you predict easily which of the two sides of the coin will show up? Mind you, a coin has got 2 faces, a head and a tail. Again, it is difficult to predict which of the 2 sides will show up. Now, to understand this, you need prediction. Normally needs the concept of theories, the concept of probability theory. Consider the case given below there. Out of the last 4 games, Simba won 3 against Yanga. Out of the 4 games they made, the last 4 games, Simba won, emerged the winner in 3 against Yanga. Now someone wants to find what will be the chance of Simba emerging the winner in the next game. You need to have the theory of probability to do it. Now the theory of probability, it's both mathematical and experimental. Let us use the same case there to see how is it mathematical. That in the last 4 games, Simba had emerged the winner in 3. That means here, Simba has won 3 out of 4. And again, Simba has lost 1 out of 4. Now, if someone wants to predict what will be the result in the next game, it is that the chance of Simba to become a winner, to emerge a winner in the next game will be 3/4. And the chance of Simba losing the next game, it is 1 out of 4. So if you are competing to predict, I believe that most of you will predict that Simba would emerge the winner because of this mathematical reason. This we call experimental. 4 experimental has shown that Simba had emerged the winner in 3 games. That's how we can define. So by definition, probability is the mathematical measure of chances which is based on experimental results. There are things which will also be used in the probability. That is the possibility set and event. We need to know possibility set and event. There are two things which you have to know them. Possibility set and event. We shall start with the first one. You talk about the possibility set. If you take a die and you roll it, we normally say to roll a die. You roll it, just push it. It will be rotating somewhere here. Now, the expected results, as we know that the die has got 6 faces, numbered 1 to 6. Each of the face has equal chance to show up. Now, if you roll this die here, what you expect to show up is either 1, 2, 3, 4, 5, and 6. Any of these 6-sided can show up. Only one has the chance to show up. When one has shown up, others has got no chance. Now this possibility, these all elements or these possibility results which can show up, we call it the sample space. We call it sample space, which is denoted by S, or we call it the possibility set. That's I'm talking by rolling a die. If I throw a coin, this one here, if someone asks what will be the possibility set, the sample space, it is either head or a tail to show up. Can you give me any example of in daily life to find the possibility set? Think of a woman who is pregnant. Can you predict what's the sample space? The baby born. Will the baby born be a boy or a girl? If I ask you what the possibility set, it is either a girl, a baby boy, or a baby girl will be born. All these are examples. That is all about the possibility set. As I said, the possibility set it's normally denoted by S. And if I want to show this one here, now in our case here, the possibility set will be 1, 2, 3, 4, 5, and 6. If I toss a coin, what will be the possibility set? The possibility set will be S is equal to, if I present them in set notation, it is either head or tail to show up. That is what we call the possibility set, or in another words, we call it the sample space. An event. An event. A specific outcome is called an event, and the number is denoted by E. If the number greater than 2, consider there's a case there, if the number greater than 2 is to show up when you roll a die, if the number greater than 2 is to show up by rolling a die, that means if you look at the sample space here, numbers which are greater than 2 are 3, 4, 5. Now 3, 4, 5, and 6, according to the question there, it is our event. We say that if the number greater than 2 is to show up by tossing the coin, then the outcomes 3, 4, 5, and 6, these are the events. The outcome 3, 4, 5, and 6. This is the event, which is denoted by E, and in set notation, it should be written this way. That is what we call an event. You can differentiate between the possibility set or the sample space and the event of the experiment, of tossing anything, of tossing, for example, of a coin. Let us have a look on another example. That was a die. We have also a coin here. You are tossing it. The possibility set of a coin is either a head or a tail to show up. Now, if you are being specific that it is the head to show up, now the head is your event, which is represented in form of set notation as H. That's how we can find the event. Not only this, you can even come out with yours. There's a lot of things. That is, for example, today it has been raining. You need to find that there is the possibility of raining or not raining. That's the sample space. But if you are specific that today it will rain, that specific, we call it an event. But there is a time an event may not occur, that you predicted that a baby born will be a boy, and instead a baby girl is born. How do you represent this one? I'm rubbing here. Such kind of an event, we call that, such kind of situation, we call that event as a complement of an event. That a pregnant woman, a mother who is pregnant, we're expecting her to have a child. Now, we want to know, we want to predict whether a baby born will be a boy or a girl. Now, our sample space here is baby boy or baby girl. Any of the two can show up, can be born. Now, if our prediction, if the prediction is that the baby born is to be born, I mean the baby boy is to be born, so our event, what will be our event? Our event will be this one, be here. But that's what you predicted, that a baby born will be a boy. But instead of being a boy, a baby girl is born. Now that we call it a complement of an event, and it is denoted by E dash. So the E dash of this sample space here, it is the girl. The prediction was a baby boy to be born, but instead it is the baby girl who has been born. So you cannot say E is your event. No, it means you denote it as the E dash. We read this as the E complement. We read it as the E complement. Complement. As E complement. Let us have a look on some few examples which can help us to practice on possibility sets, event, and a complement of an event. I'm rubbing here, and I want to write an example of a question here. Now, after having seen how to determine the possibility set, that is the sample space, and the events, let us have a question here which can help us to see whether to what level we have understood how to determine the possibility set and the event. We have the question here. A die is rolled once, and the result is recorded. 1. We need to find the sample space. We know the die has got 6 sides, which all the sides have equal chance to occur. So our sample space here, the possibility set that if you roll a die, you are likely the possibility set, the sample space, which in another words we call it the possibility set, the sample space, which is denoted by S, will be equal to, will be what? Will be 1. That means it can either show 1 or 2 or 3 or 4, 5, and 6. That is the sample space. We have answered the first part of the question, the sample space, when you toss a die, I mean when you roll a die. The event that an even number occurs. Look at this sample space. Do we have even numbers? Yes. We have 2, 4, and 6. So B, this was A, B, the event even numbers. The event even number to show up. The event, if the event E will be 2, 4, and 6. This is here, it's 4. That is the event of even numbers. And the last part, the event that an even number does not occur. We said that when an event does not occur, this is known as complement of the result. It is denoted by C, the complement. That means the event does not occur. The complement. A dash, the event that even number does not occur. What are numbers which are not even? It is 1, 3, and 5. 1, 3, and 5. That's how we can determine, we can determine the possibility sets, the complement of an event, and the event. At your own time, you can try this one here. Let me write one for you, which we'll have to do it, and I'll have to check it later. There is a question here. I would like to do it at your own time later. There is a question which says, write the possibility set of each of the following experiment. Write the possibility set, of each of the following. Of each of the following. Code this is number 1. The first one is here. A die is tossed. The first showing up is red. The die is rolled. The die is rolled. The die is rolled. And the face showed up is red. That's a question. Another question there. 2 teams play a football match. 2 teams play a football match. 2 teams play a football match. A football match. Write the possibility set for this one here. That is all about the event and the possibility set. And these questions here will help you at least to be able to write the possibility set. When a die is rolled and the first showed up is red. 2 teams play a football match. You can write the possibility sets. That is all about the possibility set and event. When I come back, we shall have a look on the probability now of an event. Let's continue and have a look on the last part for today. That is the probability of an event. After having seen how to determine the event, how to determine the probability set, now there is an arithmetical and we call it numerical representation of the results. That now we are going to the probability itself. Probability of an event. Let's think of 2 things here. You have a die here. Let's say if I roll this die 50 times, or 100 times, or 1,000 times, all these are experiments. Or if I toss this coin here 10 times, 100 times, I'm showing you an example here that you're tossing. I have head, tail, and here you have the number of toss. That if I toss for the first time, maybe it is the head, the head which will show up. I toss it again, it is either the tail which will show up. You toss it again, it is again either the tail. You toss it again, maybe you will have the head. Toss it until 100 times, or 1,000, or 10,000 times. The proportion of the head or the tail against the number of throws is what we call the probability of an event. The proportion of the head or the tail to show up is what we call the probability of an event. That is, toss a coin. Let us just write explanations here. In general, probability of an event. Probability of an event is the ratio of the number of events to the number of sample space. To the number of sample space. That is, the probability of an event, it is noted that way, is equal to the number of the events, to the number of sample space. The number of sample space. That is, probability of an event is equal to number of events. It is written this way. Number of events divided by the number of sample space. The number of sample space. This is the formula which used to calculate the probability of an event. The probability of an event. Let us have a look here. I have already defined what is NA. I have also defined what is NS, number of sample space, number of events, and this is the probability of an event. Let me lab here so that we can discuss one example together here. Here. Example. A drawing pin was tossed 1,000 times. We have example here. Call it example number 1. A drawing pin was tossed, not tossed. Drawing pin was tossed, yes, 1,000 times. And the number of tosses where the pin fell flat. The number of tosses where the pin fell flat was or is 568. Finally, calculate the probability that when a such pin is tossed, it will fall flat. Calculate the probability when such pin is tossed, it will fall flat. That is our question. We need to discuss it. Now, in order to solve or to find the probability of an event, the first thing is to know the possibility set or the number of possibility sets. The possibility set. We need, do we have the number of possibility set from our question? It means the number of tosses. How many times was the pin tossed? 1,000 times. That is the number of sample space. We have, this is 1,000 times. Number of events. The number of events of falling flat, not falling flat. It was 568. Number of event. This is 568. What we need to calculate here is very simple. What is the probability of an event? Take our formula here. All right? The probability of an event is equal to number of events divided by number of sample space. The space here is not enough. Let me lab here so that I can create another space to finish up our calculations. The probability of an event, PE. What is our number of sample space? What is the number of events? It is 568. 568 divided by number of events, number of sample space. That is 1,000. It's a simple arithmetic there. 5, just count the number of zeros here. So will have a point here. That is 0.568. That is the probability of an event. When time allows, next time when we meet, we shall have a look on more questions based on the number of events, number of sample space, and the probability of an event. But at the moment, I'll give you an assignment. I want you to go and feast your book. Tanzania Institute of Education, Book 4. Go to the 4th topic, Exercise 4.2. You will find a number of questions based on determination or how to determine this sample space, how to determine an event, and how to calculate the probability of an event. Until then, I'm your teacher, Pascal Titus Majebele. Goodbye for now.
Let's study, be educated. Elimu ni kazi. Elimu ni kazi. Let's study, be educated.